A right square pyramid with volume 54 has a base with side length 6. The 5 vertices of the pyramid all lie on a sphere with radius m over n, where m and n are relatively prime positive integers. Find m plus n. Okay, so I think we just sketch a diagram. The diagram will be a two-dimensional projection of what's going on, so we'll have to, like, you know, remember that. But there's my sphere with some, basically they're asking us to find the radius, of course. So it's a right square pyramid. So this will be the top of the pyramid. And this, although I'm drawing it as one line, is meant to be, that's a square. And if I connect this vertex at the top to all 4 vertices down in the square, those of course give you know, triangular faces. But this is we're looking straight on to something which is a, if I could rotate this towards me, then I would see a square down at that bottom. Okay, the base has a side length of 6. Let's call this S. Okay. These angles are not meant to be, in fact, these angles are misleading because, you know, if I call that theta, that's not actually the angle between this line and the base, because we've lost the depth, we've lost the 3-dimension thing there. I'm not sure if I'll use that angle necessarily to figure this out. There's an origin somewhere, and each point is on the sphere, radius r. So how do I want to set this up? If I draw the picture from above, then I have a square. Of course, this has a side length of S. The peak of the pyramid, of course, lies directly over the center of the sphere. That side length is S. And again, this distance here is not the radius because we only see that distance. So in fact, we can figure out this distance. This is kind of complicated. This distance here is that distance there. Do I want to just approach this with all this geometry, or do I want to be a little bit cheeky? And if I take the 4 points corresponding to the base of the pyramid and just assign them polar coordinates, or spherical coordinates, I guess, we might be able to set up a system of equations and figure out everything we need. It's a little bit overkill, but I think I'm going to do that. So P1 up to P4, these are going to be the points on the base. And each PI is going to be R times, oh, but the polar coordinates are actually quite messy, aren't they? Goodness. So theta I don't actually have to worry about because each theta is just going to be like 0, 90, 180, 270. But phi, I don't actually know what it's going to be. But phi determines the z coordinate. So an arbitrary point in polar coordinates, r times okay. So each pi, theta is just pi over 2 times I. Let's call it, let's call it pk. Pi times k over 2 times cos of phi sine of pi k over 2 times cos of phi. I don't need this diagram anymore. Oops. Oh my goodness. Let's do it the slow way. And sine phi. So that is coordinates of my 4 base points. And P0, which will be the vertex, this is R times 0, 0, 1. Okay. Now the volume is equal to the area of the base times the height divided by 3. That's true of any pyramid or cone type shape. So I know that 54 is the volume we're given. The area is the base, which is 6, so 36 times h, let's rewrite this as 36 over 3. So 54 is equal to 12 times h. 54 over 12 is what? Divide that by 4 is that divisible by 4? No, it's divisible by 3 though. 18. Do this slowly. H is 27 over 6. So H is Oh, of course, 9 over 2. Is that right? $54 divided by 6 is 9. 12 divided by 6 is 2. Okay. H is 9 over 2. Now, H is also equal to the difference in the z coordinates. H is r times 1 minus sine phi. So 9 is equal to 2r 1 minus sine phi. Am I missing? I have two variables here. Two variables but one equation. I guess I can set up another equation using the Pythagorean theorem and this radius. So this distance is 1 minus sine phi. I mean, phi is negative, so sine phi is negative, so it's 1 plus the absolute value of sine phi. But I should also write this distance, sorry, and not one, like, it's r plus r, 1 minus sine phi times the radius, okay? So the other thing I should write down is r squared is equal to half side length squared plus half side length squared plus that distance squared. Okay. So r squared is equal to s over 2 squared plus s over 2 squared plus r sine phi squared. And I know s, right? S is 6, so r squared is equal to 18 plus r squared sine squared phi. That's just Pythagorean theorem on, you know, I have that distance squared plus that distance squared plus the height out of the plane squared is equal to the radius squared. Does this help? Well, r squared times 1 minus sine squared phi is equal to 18. What if I take the equation here and square it? So I have 81 is equal to 4r squared times 1 minus sine phi squared. And I want to divide one equation by the other. That won't give us r, but it'll give us an equation for sine of phi, or maybe like something like that. Okay, let's do the bottom equation divided by the top equation. Okay, so I have 8 times 1 minus sine phi divided by 1 plus sine phi is equal to 9. 8 minus 8 sine phi is equal to 9 plus 9 sine phi. Interesting. Okay, so 8 minus 9 is negative 1 is equal to 17 sine phi. That does not look like a nice number. But I don't really care what phi is, I care what sine phi is. So sine phi is equal to negative 1 over 17. Okay. Now, let's take that. 9 is equal to 2r times 1 minus sine phi, which is 1 plus 1 over 17. So I have 9 is equal to 2r times 18 over 17. 9 times 17 divided by 2 times 18 is equal to r. 17 over 2 times 2. So I get that r is equal to 17 over 4. So in this case, the relatively prime positive integers are 17 and 4. So m plus n is equal to 21. So if the radius, if that's 17 over 4 is a bit larger than 4. A bit larger than 4. Larger than 4, does it make sense that this is the angle that it's below here, below the plane, is 1 over 17. No, sine of that is 1 over 17. Okay. I'm just trying to estimate whether this is a reasonable number or not for the side length to be equal to 6. I mean, setting the problem up, I don't know if this spherical coordinate way is the best thing to do. Like maybe I probably could have just done it directly with the geometry, but the key is the angle. If I draw the plane through the origin of the sphere, then, and if I connect the origin to one of these points, there's an angle below the plane that line segment makes. That's of course what I've called phi, or I guess negative phi in this case. But a lot of the geometry should be written in terms of sine of phi, right? If phi is equal to 0, then this point would in fact be level with the origin. And as phi decreases and becomes more negative, the z coordinate becomes sine of phi. So from there, if you know the z coordinate, you can write something for the height, right? It's this distance, which is r, minus the z coordinate there, and then I guess you also want that Pythagorean relation that I wrote down for r squared in terms of s over 2 squared, another s over 2 squared in that direction, plus this height squared. And then, yeah, I found it a little bit easier in terms of how the equations were set up to solve for sine of phi instead, rather than r. But maybe there's something you can do to more easily solve for r directly here. But anyway, that's the answer that I get. I hope it's right. If it's not, I'll put a message somewhere, let you know. Thanks for watching.